Hello everyone, my name is Anushri, 4th year BE in Information Science and Engineering student at Sri Venkateshwara College of Engineering, Bangalore. Today's topic of my presentation will be on subject cryptography and network security. What is DES? So let's discuss about DES, that is Data Encryption Standard. Data Encryption Standard is a block cipher with a 56 key length that has played a significant role in data security. Data encryption standard has been found vulnerable to very powerful attacks. Therefore, the popularity of DES has been found slightly on the decline. So now there is an advanced encryption standard that is replacing the DES. DES is a block cipher and encrypts the data in a block sizes of 64 bits each, which means 64 bits of a plain text go to the input to DES, which produces 64 bits of a ciphertext. The same algorithm and key are used for encryption and decryption. With the minor differences, the key length is 56 bits. We have mentioned that DES uses a 56-bit key. Actually, the initial key consists of 64 bits. However, the DES processes even starts. Every 8th bit of the key is discarded to produce a 56-bit key. This is bit positions that are 8, 16, 24, 32, 40, 48, 56 and 64 are discarded. Here in the figure you can see that 8, 24, 40, 56, 16, 32, 48 and 64 bits are discarded to bring the key from 64 bits to 56 bits. Discarding of every 8th bit of the original key brings us the key from 64 bit to 56 bits. Thus, the discarding of every 8th bit of the key produces a 56-bit key from the original 64-bit key. DES is based on two fundamental attributes of cryptography: substitution, also called as confusion, and transposition, also called as diffusion. DES consists of 16 steps, each of which is called as a round. Each round performs the steps of substitution and transposition. Let us now discuss the broad level steps in DES. In the first step, the 64-bit plain text is handed over to the initial permutation function. The initial permutation function is performed on the plain text. So the initial permutation consists of interchanging the positions of the original 64-bit plain text. Next, the initial permutation produces two halves of permuted block, saying left plain text and right plain text. Now, each LPT, that is left plain text and right plain text, go through 16 rounds of encryption process. In the end, left plain text and right plain text are rejoined and final permutation is also performed on the combined block. This result is of process produces the 64-bit ciphertext. In this process, first we have the 64-bit plain text, and the 64-bit plain text undergoes the initial permutation. In initial permutation, we are going to interchange the bits position in the plain text, and then the 64-bit plain text is converted into 32-bit left plain text and right plain text. Both the left plain text and right plain text go through the 16 rounds of encryption process in DES, which consist of expansion function, substitution function, and transposition function. And then finally, with the use of a key and the rounds which are performed on the left plain text and right plain text, we are going to perform a final permutation on the 64-bit plain text to convert it into a 64-bit ciphertext. Initial permutation, as we have noted that initial permutation happens only once, it happens before the first round. It suggests how the transposition in the IP, that is plain text, should be proceed as shown in the figure. For example, if say that the IP initial permutation replaces the first bit of the original plain text block with the 58th bit of the original plain text. The same rule applies to all other bit positions shown in the figure. This is nothing but jugglery of the bits position of the original plain text. In the figure you can see that the 58 bit is swapped with the first bit. So that is what is the initial permutation. As we have noted that initial permutation is done, the resulting 64-bit permuted text block is divided into two halves. Each half consists of 32 bits, and each of 16 rounds in turn consists of the broad level steps outlined in the figure. Key transformation, that is initial permutation and key transformation is nothing but 64-bit plain key is converted into 56-bit key, and then 56-bit key is left shifted and perform the permutation choice 2, and it becomes a 48-bit key, and that is XORed with the 48-bit plain text, right plain text. That is for the expansion permutation. Expansion permutation takes the 32-bit right plain text and it converts it into a 48-bit plain text. So that is XORed with the key. The result is given to the Xbox. Xbox converts the 48-bit text into the 32-bit plain text, and the pre-box is nothing but transposition box. Transposition box just converts the plain text from the 32-bit plain text to 32-bit plain text, but just interchanges the position in the bits. And then XOR is performed between the Li-1 and Ri-1, and then swap is performed. Key transformation. We have noted that initial 64-bit key is transformed into a 64-bit key by discarding every 8 bit of the initial key. Thus, for each 64-bit, 56-bit key is available. From this 56-bit key, a different 48-bit subkey is generated during each round using a process called as key transformation. For this, a 56-bit key is divided into two halves, each of 28 bits. These halves are circularly shifted left by 1 or 2 positions depending on the round. For example, in the round numbers 1, 2, 9, 16, the shift is done only on the one position on the other rounds. The circular shift is done by 2 positions in the other rounds. The number of keys bits shifted per round is shown in the figure. After an appropriate shift, 48 of 56 bits are selected. From the 48, we might obtain a 64 or 56 bits based on the requirement, which helps us to recognize that the model is very versatile and can handle any range of requirements needed or provided. For selecting 48 bit of the 56 bits, a table is shown in the figure given below. For instance, if after the shift, bit number 14 moves to the first position, bit number 17 moves to the second position, and so on. If we observe the table, we realize that it contains only 48-bit positions. A bit number 18 is discarded like 7 others to reduce the 56-bit key to 48-bit key. Since the key transformation process involves permutation as well as selection of 48-bit subset of the original 56-bit key, this is called as compression permutation. Expansion permutation, as I already said. Recall that after the initial permutation we had two 32-bit plain text areas called as left plain text and right plain text. During the expansion permutation, the right plain text is expanded from 32 bits to 48 bits. Bits are permuted as well as, hence they are called as expansion permutation. This happens on the 32-bit right plain text is divided into 8 blocks, with each block consisting of 4 bits. Then each 4 bit of the previous step is expanded to a corresponding 6-bit block, i.e. per 4-bit block 2 more bits are added. That's all for this video. Thank you.